So after we have modeled our 3D sci-fi gun, now it's time to make a shader for it and texture it. I challenged myself to see if I could do only with procedural texture, and this was a fun experiment. I'll show you all my shader nodes and how easy it is to use them. All it took was 5 steps and a little bit of hand painting, and as a bonus I'll give you a simple way to create a mask texture from a bevel shader, like a cavity mask. Step 1. Generate the base textures. This was our 3D model from a previous video, now unwrapped and ready to be textured. Now we can preview the first texture here, by holding down Shift plus Ctrl plus left mouse click. Now we have a direct preview of that texture on our 3D model, which is the same thing if we connected the texture to a material output, like so. For you to be able to use this, it's a native add-on for Blender, the Node Wrangler. Make sure yours is turned on so you can preview the shader nodes. So let's see our first step to the base textures, a Musgrave texture and 2 noise textures. And here we start our magic. Just by adding a math node to subtract by 0.7 the third noise texture, we get this type of texture, which looks like a dust particle texture. You can toggle any node in the shader tree editor by pressing M. It's going to mute or unmute a node. We can see exactly what it's doing. And I can change this value and see what is happening with the noise texture. So we are adding to a color mix here those particle textures on top. Let me zoom in and mute so you can see it. These tiny speckles will make a difference on the further effect chain. Then after that I just increase the contrast by raising the levels of the dark parts. The Musgrave texture is being darkened a lot and will be used as a base to our albedo color. If I zoom in, you can see it's not perfectly black. Depending on where you are seeing this video, it may be hard to see it. We are using a color ramp to give a nice dark texture to our material as its base color. This is the first step on our texturing process, and here's how it behaves on a principal BSDF shader. Still looks pretty generic, but it's a good base to start working on. So this is the albedo entry and this is the roughness entry. Step 2. Generate the metal textures. Now here on step 2 we'll be adding a lot more procedural texture and mixes. We have here a wave texture which looks like this. It's going to be a good texture to emulate something like the brushed steel textures. Then here we have from step 1 the roughness map we were preparing before, which comes from the mix of these 2 noise textures. We split it in some different parts. Here we have increased its contrast a lot by crushing the colors using a color ramp node. I can mute it so you can see what it does. Down here we have our second wave texture, this time making heavily use of the distortion parameters and increasing its scale a lot. You can see that both are wave textures but look very different. The magic is in the numbers. Here I can reduce the detail roughness so you can see the effect it gives. And here's the scale, so you can use the same textures to give completely different looks. And lastly, here we also have a copy of step 1 roughness map crushed by a color ramp node. And here we have a subtract math node, which gives this third unique texture. And here we would like to color it light steel blue. You can see how it looks like. I plan to use this as a base texture color for the barrel of the Sci-Fi handgun, and I can mute the color mix so you can see exactly what it's doing. And also change the factor here. Notice that we are using mix, so it replaces the color. The top texture here is also being subtracted using a math node to give more noise to the wave texture. And it is also being colored by a color ramp with a very low contrast values. Then let's scroll down here, and here we have 2 image textures which I just painted pure white, the parts I want to be metallic, and pure black, the parts I don't want to be metallic. And here I have separated the mask texture by isolating the barrel. I invert the mask to be multiplied over the first one, creating a third mask of just the bark part of the gun. And this mixture is used as a factor texture for the Mix RGB color node here, which results in this effect. Here we have the dark noise texture from step 1. And here's the cool thing. You can split any node link in the shared editor by holding down Shift and press the right mouse click, allowing you to reorganize node links to be more visually clear. So here we have as the factor, we have the metal mask texture which we generated from the painted pure white and black image textures before. Entry A here is the dark noise from step 1 we just did, and entry B is our color metal from this current step. So we are adding B on top of A using the mask as a factor. If I unlink the factor here, you can see that everything now is B, which is the colored part. And you can play with the factor as a numeric value to see exactly what it's doing. So the factor image being assigned here will be converted to a mask textures. The lighter parts of the texture will be converted to 1, and the darker parts of the texture will be converted to 0. Next, in the effect chain, we have another color mix, adding elements B, which comes from this texture. So we are taking A, which was our previous texture, adding B, which is our second texture using the factor, which if you remember, it was the mask from the barrel only, which I painted inside Blender using texture paint and save it as an image. And here I can mute it so you can see exactly what it's doing. So just recapping our effect chain, all of these textures are being mixed originated from our step 1, which were generated by 2 noise textures and 1 Musgrave texture, which comes to step 2, mixing with the wave texture, then it's added here. Then that is converted to grayscale roughness map using a color ramp, and it is also being used as a base color to define a shader of step 2. And this is the result of step 2, the textures on its respective slots. We now have 3 types of distinct textures: our brushed steel backside, the barrel, and the dark noise plastic. And here we can isolate each enter to see exactly what is being fed to the principal BSDF. Note that the mask textures we used previously on the color mix is being fed here as a metallic map, and these emission nodes are here for baking. Basically, it renders this map as a new image textures, so it can be used further in the texture process. So let's see the difference from step 1 shader to step 2 shader. Here's the final result of step 1. And here's the final result of step 2. Let me zoom out and toggle between both so you can see exactly the differences. We have added the brushed steel on the back part and the texture for the barrel. Step 3. Adding AO, cavity, and some effects. And here is step 3, adding the ambient occlusion, the cavity shader, and some effects. So if we test our cavity shader, we can see that nothing happens. That is because at the moment, the bevel shader does not work inside Eevee. It only works on cycles rendering. So let us go back here on the layout workspace and change the render engine to cycles. Now if we go back to our shading tree, voila, our cavity shader works now. And here's how to create that cavity shader. Make sure you are using cycles to render so you can preview the shader. Add a bevel node, a geometry input, a vector math node, switch it to use dot product, a color ramp to fine tune it, then to preview I will use an emission shader. Now let's connect everything together. And you can see it is already working. We can now invert the color ramps to create a cavity mask. Here on radius we can set how far we want the bevel effect and increase the samples to increase the detail. You have now a cavity mask for cycles rendered, which works after being baked on the texture image on Eevee, which is the one I used to make that texture. So that is how you get that cavity shader, which we'll be using on the roughness map, which you can use to many different applications. So here we have our roughness map, which was baked from step 2, which we can come here to see it. And here we can see something interesting. The procedural textures will have infinite resolution because they are procedural. When we bake it, they get mangled together on the pixel resolution on the baked image. Here you can see the procedural noise bits, highly detailed. And here in the baked version, you can see we lost some of that detail and can get somewhat blurred out on the pixels. This isn't a bad thing. Sometimes you want this to mix procedural textures and give some flavor to the texture. You can see it's the same we'll be using on step 3, now saved as a baked image. Here we have the metallic map, baked from our last metallic map from step 2 as well. Here we have our diffuse map as a texture image as well, baked from step 2. And here we have our ambient occlusion map, generated from cycles baked render pass on ambient occlusion. Together with the diffuse map as a multiplier, we can see the effect it gives to diffuse texture. It's a great way to make your 3D geometry pop out and create nice details for the diffuse texture. Down here we have the roughness map baked from the step 2 as well, and our cavity mask baked as an image texture. So I am inverting the mask, to also be added as a multiplier on top of the diffuse and ambient occlusion. It doesn't work like the ambient occlusion, but I like to use here to enhance the geometry a little more. And we can see it in action with the ambient occlusion. You can see it adds interesting details for the 3D geometry. This is the shader final from the step 3. And down here is the mixture of the cavity with the roughness map from step 2. And you can see if I toggle the details it gives to the roughness map. The cavity masks make incredible difference to the roughness map on the shader. I think it looks way better with it. So this is the final result from step 3, and this is from step 2. Step 4. Hand painting. Now on to step 4, I did some hand painting on the diffuse, roughness and metallic maps, and here's how it looks. So let me grab the base color from the step 3 to compare it to the step 4 so you can see the hand paint work on the diffuse map. So this is the diffuse map on the step 4 hand painted, and this is the diffuse map before the hand paint work. You can see I painted the handle brown and darkened some areas. Now let's grab the roughness map from step 3 to compare it to step 4. Here's the roughness map from step 4 hand painted, and here is the map from step 3. You can see most of the work was on the roughness map. And here's the error that I missed. Using the mirror modifier when I was painting, the bullet extractor was painted on the other side as well. Whoops! You can see there is a dramatic difference. I can plug in the roughness map from step 3 so you can see exactly what it looks like. And you can see that the hand painting makes a difference. And all I did was to paint over the roughness map generated from step 3. Lastly, here's the metallic map from step 4, which I made the mistake of painting with a color texture, and also another mistake was to save it as an RGB texture when the metallic map only uses grayscale values, but I corrected using the hue saturation node, and when I will save this as an image file, it will work properly. So let me split here the metallic map from the step 3, so you can see the difference to step 4. So this is the step 4 metallic map, and this is the step 3 metallic map. You can see I increased the range of the metallic map and painted the handle as well. So let me plug the metallic map from the step 3 so you can see the difference on the shader. Metallic maps influence greatly the specular colors. As you can see here, the handle specular is white when we have no metallic, and brownish now that we have assigned it with metallic values. This is assimilated from the metallic surfaces from the real world on the principal BSDF automatically. So this is the final result of the step 4, the hand painting process, which I used a concrete texture to paint it using the stencil mode on the texture paint. I will probably make a video on this as well. So this is starting to look pretty good. Step 5. Adding final details. I rebaked most of the texture back again to the image textures. And here I added some textured elements to the handgun. I painted using GIMP to generate the font text and painted using the stencil on the texture paint. Then I colored the text to an orange tint, then multiply it with a lot to get mixed as a diffuse color. And by using the text image as a factor mask, I can mix only with the text from the base color texture image. So I am adding B, which is the color text, on top of A, which is the diffuse texture baked from step 4, using the text texture as a white and black factor mask. And it can get mixed on the diffuse color of step 5. Now as you notice, step 5 is looking a little different. I did some further painting on the diffuse map. Let me grab the diffuse from step 4 and compare it to the step 5. So I removed the color from the handle and painted some details. This is how the final result looks like. We have here the text mixed with the shader pretty well. While it's not super high res, it adds quite the detail to the handle. Now if we compare the metallic map, I didn't change nothing. And for the roughness map, some minor changes. Then I just added the text to the roughness map using a color mix as well. If we change the factor, we can see it in action. On the final shader, this makes the text noticeable even if the light shines through it. Now it's debatable if that's better or worse. I think this added detail makes the text pop up a little more. And this is the final product at the moment. So let me duplicate the gun and just rotate to see it entirely. And I'm going to change some things here. Let me separate each shader to see the steps in action. So here we have step 1, the base texture generated. Then here we have step 2, which were the metal textures. Step 3, we added the main effects, the ambient occlusion and the cavity mask. Step 4, we hand painted it, changed its appearance quite a bit. And step 5, we added the final details. And we can change here the HDR environment to see how this shader will behave on another type of light and reflections. And you can see that depending on your environment, the same material can look drastically different. You should always test your materials on different light situations to see if it behaves properly. And here's the 5 steps on a different HDR environment and the final result. That is all I have for today. Subscribe and make sure to stay tuned. I'll see you on the next one.
Oi, oi, oi,